All right, hello everyone. This is a video to help you complete part 2 of homework 2. We use this as a general tutorial how to access your software that we'll be using, and hopefully we'll have some idea of how to begin with data recoding that you will need to do ultimately for your projects. So, I start off with the Google homepage because I can never quite remember the URL for UCF apps. So I just Google UCF apps. There it is. And I log into it. You want your NID and your NID password. I think mine's changed, so I need to actually put a new one here. Alright. So it pops up with all of these programs. Now, one thing I think that a lot of people forget to do, and it causes some problems accessing the files, is you need to go into web courses through here. Don't go into it through your normal route. When you access it this way, it knows that you have the program that is necessary to see these files that we're going to be using. So click on web courses, let the hamster run around the wheel for a while, and on it goes. Now when it does come up, it'll look just like it normally does, except the difference is, don't worry about that. Yeah, not now. All right, so it wants you to log in again. You know, even though you just did it. I'll maximize it here. All right, then you'll get your dashboard and all that other stuff just like you normally would. Now, I'll do this for the online class, even though this video will be used for both. It works the same for both. Click it. Ta-da. All right. Oops, wrong class. Let's see here. 4450, that's what we want. There we go. Now, the file I'm going to use for this example is the exer-1.save. Now, for your homework, you're going to be using demo.save. We'll use this for the example. Let's say it can't be displayed with Canvas. Of course it can't, but you just download it. And then down here in the bottom left of your tray, you'll see the actual file. And on it goes. All right. Be ready to be patient when using these programs. All right. So we have, this is the data view. This is where it says all of the answers given by each individual are recorded. For example, row 1 is person 1. And all of these different things, all these numbers, are how they answered the various questions in the survey. Now, what are these columns? Are the actual questions that were asked. Now, these are just mnemonics. It's hard to tell exactly what they mean. So you go to variable view, and ta-da. If you look over here at label, and you kind of expand it out, you will see what the question was, more or less. So, for each person, they ask their opinions about affirmative action, their age, their subjective class identification, so what do they call themselves, upper class, middle class, so on, confidence in the press, confidence in television, whites being hurt by affirmative action, and on it goes. See how many questions do we have here? We have, well, quite a few. There should be 47 in yours. 48 through 55 are ones I've created over time. And don't worry, I'll show you how to do them as well. So, to your assignment. What you do when this comes up is, say you have a concept that can't be directly measured. For example, racism, or even something like attitudes about abortion, which are more nuanced than really one question will allow you to get at. How these surveys work is they'll ask a battery of questions that kind of get at different dimensions of that concept. And for us, if we want to use these concepts, what we need to do is take, say, several of these variables, say the effectiveness of anti-terrorism measures, right? We have a few of them here. Say we wanted to get an overall picture of how effective people think these measures are by adding up the responses to each of these questions. That way we get a more nuanced measure for each person. How effective do they think anti-terrorism policies actually are? Let's see here. We'll keep it here. Let's see here. There's another one. Here we have these fee child, fee fam, fee hire, free speech, or fee preschool. And these ones ask about more traditional gender roles. There's another example of them. For example, this one asks them if they think the mother working does not hurt children. This one asks if they think it's better for the man to work, for the women to tend home. This question asks if they should hire and businesses should hire and promote women. This one asks if preschool kids suffer if the mother works. And how these were possibly answered, you go over to values, right? See, mother working doesn't hurt children. And 0s and 8s and 9s are useless to us, but the 1 through 4s are strongly agree, disagree, and strongly disagree. Okay. Then we go to fee fam. It's better for a man to work, women to tend home. Look at that. It's strongly agree, strongly disagree. You know, you do it for each one of these. All right. So let's see if we can find a good example that'll help us give an example for your homework. I think the police abuse one's probably the best one. I'm going to go ahead and get rid of the ones I've created here. I just highlight it and hit delete. That does it. So we can make new variables for you guys. Alright, so this battery of questions asks about people's attitudes about how the police go about their work. And each one of these asks if it's okay if a police officer it's okay for a police officer to strike a suspect if, and it has these different situations. The citizen said vulgar or obscene things, if they were attacking the policeman with their fists, if they were attempting to escape custody, and they have the ever approve of police striking citizen. Those have citizen question as a murder suspect. So, if we want to get an idea of how people feel about police striking citizens, we would probably want to use several of these, all except for probably the ever approve, because it's kind of a holistic measure. But we have 1, 2, 3, 4 different questions here that ask about under different circumstances can police strike citizens. All right. Now each one, we look at their values, say if they said vulgar or obscene things. These are yes/no questions. So 0 means it wasn't asked these people for whatever reason. 1 is a yes, 2 is a no, 8 is don't know, and 9 is didn't answer. Now, we can't do anything with the people who aren't asked, or the people who don't know, or people who didn't answer. So we're just going to focus on the 1s and 2s. All right. So in order to get these things together, I said before, we just add them up. But the problem is that 1s being yeses and 2s being nos, if we just add them all together, it becomes very difficult to interpret this. So somebody they said no to all 4 questions. Their score would be an 8. If they said yes to all the questions, their score would be a 4. This is difficult to interpret in any real way, right? What we want to do is turn it so that people who said yes to all 4 questions would be a 4, and people who said no to all 4 questions would be a 0. That way we have a count. How many times they said yes to these questions, but it would be 0, 1, 2, 3, or 4. So to do this, without further ado, what you do is you're going to go to transform up here at the top. And we'll start with poll abuse. Go to transform and recode into different variables. You never want to use recode in the same variables. I'm just going to put that out there. It's just not your friend. You're going to want to use recode into different. And, oops, let me get rid of that. You see this kind of gives you the labels here, at least in mine. Maybe it'll give you the names. But if you want to get rid of the labels and get the actual variable name, which I think is more useful, you right-click it. Click the little radio button for display variable names, and voila. Okay. So the variable we're going to work with first is pole abuse. Put the input variable there. Now we want to give it a new name. Pole abuse. And what we're doing is we're turning it into a binary measure. Zeros and ones means binary. So pole abuse binary. And now we got to tell SPSS which value, how we're going to interpret the values from this measure into this new one. So old and new values. All right, so in the original variable, I told you, ones were yeses, right? So old value of 1, we want our new variable to still be a 1. We want yeses to be 1s. We liked that part. That part was easy to do. So we'll hit add. That's it. Now the problem with this measure were the 2's, right? So the old value of 2, in our new measure, we want to call it 0. So 2, remember, was no in the original measure. Now we want no to be 0. Go to add. And there it goes. Now remember I talked about the 0s, the 8s, and the 9s. Now in GSS, they kind of have it set up so that the system knows that these are missing measures. So we're going to go to the system or user missing in the original, are still missing in the new. And that tells it that we're counting the 0s, the 8s, and the 9s as just missing measures, which is all you can really do with them. All right. And that's it. Hit continue. Then you got to hit change. Don't forget that part, because if you don't, this OK button won't turn blue for you, which is what you need to do ultimately. There we go. Now, here's where the tedium comes. I'm going to minimize the output. We do this for the other 3 measures. I know, it's really exciting stuff. But again, you get rewarded in the end. So let's continue on. The next one is the pole attack, which is when if they were okay if the policeman strikes the citizen if the citizen's hitting them. So we will transform, recode into different. Now we don't want pole abuse anymore. I'm going to hit reset. And right click, get out of that. And we will go to pole attack. It's going to be the exact same set of steps. So we're creating a new measure called pole attack binary. And we go to our old and new values, and the same thing still apply. The 1s for yes, we liked that. That was fine. That was going to work. We add there. Again, our problem were the 2s, so we're going to turn them into 0s. So that no is 0, yes is 1. Again, it's called a binary measure. We'll add it. And all of the junk, we're going to declare it still to be junk in our new measure, and so on. You hit continue, you hit change, and you hit OK. Now I'll do this for a couple more, and I'll show you the next step. See, pole escape. One thing you can do if you're feeling comfortable here is you recode into different measures. Let's get rid of this measure here. Go to pole escape, or pole scap, I guess. However you want to say it. SCAP binary. Go to old and new values. Hey, look, that stuff's still there, huh? It's still the same thing for each one. So you can say continue, change, and OK. Now we have a 4th one. Pole murder. Because remember, we're skipping pole hit OK because it's kind of an overall, it's kind of a catch-all kind of measure here that doesn't have a whole lot of nuance. So that's why we're kind of skipping it. But we want to see if it's okay to hit murder suspects. So we'll do that again. Recode into different. Get rid of that. Let's see here. Where's our murder suspects? Goes. Go to our old and new values. Yep, they're still there. Again, we're using the same coding scheme for each one of these, so we can just do that. And we hit OK. Now, at this point, we've made our 4 variables. We're halfway home to actually finishing this little assignment. Now what you want to do, this is always good practice, is you want to go back and check and make sure your recoding worked. So you can go up here to Analyze. You're going to use this button a lot. We're going to analyze descriptive statistics, and in this case we're going to use frequencies. Because again, what we want to check to see is that we have the same number of yeses and nos in the old measures as we have in the new ones we just made. Make sure we didn't mess anything up. So we'll display our variable names, and we'll go through our list. Let's see, we wanted pull abuse, pull attack, pull escape, and pull murder. Those are the originals. We're going to go down to our new ones we just made. Hey. And we're going to go ahead and put these in the variable category. And what this is going to do is produce frequency distributions for each one of these measures in this box. We don't need to worry about statistics or anything about it right now. We just want counts. Make sure our counts are right. Hit OK. Let's go ahead and maximize this for now. All right. So the original measure, say citizens said vulgar or obscene things. That's poll abuse. 95 said yes. 892 said no. And then we'll go look to our new one. 892 said no. 95 said yes. So it looks like it worked. We did a good job. 95 and 892 are the numbers in question. Citizen attacked policeman with fists. That's the next one. 112 and 896. And here we have 112 and 896. Escape, 737, 251. There we go. And 846, 142. All of them match up. So we did it right. It's good. Now we still have a couple of more things to do to finish the assignment. This is more of a double check kind of thing. What we're going to do, we'll minimize the output window. All right. Now what I want you to do for the assignment is you want to create this composite measure where you add them all together. All right. So you go to transform, and this time you're going to compute the variable. So we're going to create a new variable. Pull abuse composite. That should work. And we need to tell it which measures to add up. Again, I'm going to right click this thing to get the variable names. And we're going to add our new ones, not the old ones. We're going to add the new ones. So we add their answer to poll abuse binary. Whenever it's up to think, okay, there we go. Plus poll attack binary. Plus poll escape binary. Plus poll murder binary. All right, that's it. Hit OK. And it does all the thinking for you. Now, we want to go check our new variable out. Let's go to Analyze, Descriptives. Oops, Analyze, Descriptives. Frequencies, we can get rid of all these guys. We don't care about them. We want our new one. Poll abuse composite. I'm going to go ahead and get some statistics on this one, because we actually can get a mean and a median now, because when you take these binary measures and you add them together into a composite score, what you've done is you've taken a bunch of nominal level measures and created at least an interval or possibly a ratio level measure depending on some assumptions, which opens up a whole world of statistical tests you can run. Alright, so here's our poll abuse composite. So you say, 59% of the people were not, or 59 people rather, or 4% or valid percent, so 6% of the people were not okay with the police hitting the suspects under any circumstances. 18% found one of the circumstances okay. 62% found it okay under two of those circumstances, and so on. So what we really have here is kind of this measure of how accepting people are of police striking citizens. With a small percentage that say it's never okay, a small percentage is saying it is okay, then we have people in the middle. right? Which kind of, again, is what you'd expect. Right? It's a normal distribution, if you will. So we have this measure. Let's see what our mean score was. It'll be above it. It was 1.8723. So this is the first thing you did. So the first part of the assignment of part 2 was to create the new composite measure. We did it. Yay. Now there was a second part, though, that wanted to give you the high-low scores. So we want to know what percentage of people are above the mean and which percentage of people are below the mean. So we'll note here our mean is 1.87. We'll stick with that. All right? And we'll use that as our dividing line. So finally, to finish the homework, last thing you have to do is you're going to go to transform. And you're going to go recode into different. Okay? And we're going to clear this out. It's all going to be different this time. Right click, give us our variable names. And we're going to use our composite measure as our input. And we'll call it pull abuse high low. And just like we did before, we'll go into old and new values. Now we're not going to use the same buttons we used before. It's a little bit different. We're going to say 0 through 1.87, right? That's a low to the mean, is going to be 0 for this new measure. It'll be the low end. Add it. And for our high end, we can't say 1.87 again because, again, it has to be mutually exclusive categories. So we'll go with 1.88 through, and the highest score they could possibly get was a 4. Right, because there's only 4 measures, and we added them up, 1, 2, 3, 4. Here's a 1. Hit continue, change, and OK. All right, finally, we'll analyze it. We'll go to our descriptives, we'll get our frequency for our new high-low measure. Hit OK. And there we have it 2 different ways, this composite measure. So about 24% are on the low end or below the mean, 75% are above it. So we have the high-low scores. So we have 2 different ways of creating this composite measure of people's attitudes about police striking citizens. For the composite, which is a nice interval level measure, it's good stuff. We can use this for correlations. We can use it for t-tests, ANOVAs, whatever we want to use it for. The high-low is a little different. It's now, again, now it's a nominal level measure. It's a binary 1-0, but it still has its purposes. Do chi-square tests on it, or if we can use a dependent measure, we can do t-tests with it too. All of that will be coming, the test selection stuff. Well, first things first, you have to get used and get your hands dirty playing with this data, and this is how you do it. So if you follow these steps and apply them to the abortion questions in the demo.save file, you will be able to produce these 2 variables, which is what the assignment is all about. All right, good luck to you, and give yourselves enough time, because it takes a little time to get used to playing with this stuff. Oh, one last thing before I leave you. When you go to turn in the assignment, when you go to save this stuff, you're going to save it. So we just made a new data set, right? Let's get out of this output. We just made a new data set, right? We created new variables, all this other stuff, right? Now, if you were just to close it and walk out, it doesn't save it. So you're going to want to save it. File, save as, and you want to use the K drive, right? And I'm going to call it Xer, what is this here, 18? And save it like that. You always want to save the new work that you've done. Again, unless you want to do it all over again. We'll save it. All right. Now, when you go to turn in this assignment, you have to make sure that you turn it in through web courses in UCF Apps. Again, it won't know what to do with the files otherwise, and won't let you upload them. So to save everything that you do, the save files, the SPV files, which are the output files, save those to the K drive, and then log into web courses and upload your assignment from there. All right, that's all I've got for you. Good luck to you.